Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Software and application-level vulnerabilities continue to be among the most exploited areas in cybersecurity. These weaknesses are not always the result of malicious coding, but often stem from simple human mistakes, incomplete validation, or outdated components. Attackers routinely scan for these flaws in both desktop and web-based environments, seeking opportunities to gain unauthorized access, execute code, or disrupt services. In the context of the A+ certification, you will be expected to recognize the most common vulnerability types and understand the basic strategies used to prevent or mitigate them. While deep technical mitigation is outside the scope of the exam, foundational awareness is critical for support and security roles. One of the most dangerous types of software vulnerabilities is known as a zero-day. This term refers to a flaw in software that has just been discovered and does not yet have a patch or fix available. Because there is no defense in place when a zero-day is first discovered, attackers have a unique opportunity to exploit the system before anyone can respond. This makes zero-day attacks extremely dangerous, particularly when the vulnerability exists in commonly used software. The term zero-day emphasizes the urgency. There are 0 days between discovery and active exploitation, leaving organizations with little time to react. The discovery of zero-day vulnerabilities can come from many sources, including security researchers, penetration testers, and, unfortunately, cybercriminals. Some attackers find zero-day flaws and immediately begin exploiting them in targeted or widespread attacks. Others may choose to sell the information to other malicious actors, or even nation-state organizations. When responsible researchers discover a zero-day, they typically report it privately to the vendor, allowing a patch to be developed. Meanwhile, behavioral detection tools may offer temporary protection by flagging abnormal system activity, even when the specific threat is not yet known. More common than zero days are standard software bugs and misconfigurations, which also pose a major risk. A software bug is an error in the program's code that leads to incorrect behavior or failure. Misconfigurations occur when system settings, such as permissions or services, are left in insecure or unintended states. These vulnerabilities are not difficult to fix but often go unnoticed until they are exploited. Proper coding standards, secure default settings, and regular patching can eliminate many of these weaknesses before attackers find them. Even in support roles, recognizing the impact of insecure configurations is essential. SQL injection, often abbreviated as SQLi, is a well-known and dangerous vulnerability that affects web applications. It occurs when input fields on a website, such as login boxes or search bars, allow users to submit raw SQL commands to the backend database. If the application does not properly sanitize this input, attackers can use it to view, modify, or delete data in the database. For example, a vulnerable login form could be bypassed by submitting crafted input that forces the database to return valid credentials. This type of attack is particularly harmful because it targets the heart of many websites, their stored data. Preventing SQL injection requires secure programming practices. Developers must use parameterized queries that keep user input separate from executable code, thereby removing the attacker's ability to inject commands. Input sanitation, where inputs are stripped of dangerous characters or patterns, is also helpful. In addition, databases should follow the principle of least privilege, where each user or application only has access to the data and commands necessary for its function. Monitoring query logs and setting alerts for abnormal query behavior can also help detect potential exploitation attempts. Cross-site scripting, or XSS, is another critical vulnerability that targets the interaction between users and web content. XSS attacks occur when malicious scripts are injected into web pages that are then viewed by other users. These scripts can steal cookies, redirect visitors to malicious sites, or alter the content of the web page itself. There are two main types of XSS: Persistent and reflected. Persistent or stored XSS involves scripts saved on the server and served to multiple users. Reflected XSS, by contrast, embeds the malicious script in a link or request that only affects one user at a time. To prevent cross-site scripting, applications must sanitize and encode all user inputs before displaying them on a web page. This ensures that input is treated as text and not executable code. Developers should also use frameworks and libraries that automatically escape output, reducing the likelihood of injection errors. Setting strict content security policies in the web server or application can also limit the types of scripts allowed to execute, creating an additional layer of protection against both stored and reflected XSS. Another type of vulnerability that can lead to system compromise is the buffer overflow. This occurs when an application attempts to store more data in a memory buffer than it was designed to hold. The excess data can overwrite adjacent memory space, sometimes allowing attackers to execute arbitrary code. Buffer overflows are particularly dangerous in low-level languages like C or C++, where memory management is not automatic. These vulnerabilities have been responsible for numerous high-profile security breaches and remain a persistent issue in software security. Preventing buffer overflows starts with coding practices that include bounds checking, ensuring that inputs are never larger than the buffer can accommodate. Modern compilers and operating systems also include built-in protections like stack canaries and address space layout randomization. These features make it harder for an attacker to predict where to place malicious code and increase the chance that an overflow will be caught and blocked before causing damage. While A+ does not require you to write secure code, you will be expected to understand the risks associated with poorly written or outdated software. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Privilege escalation is a type of attack where an adversary gains elevated access to resources that are normally restricted. This can happen locally, where a user with limited rights gains administrative privileges, or remotely, where an attacker expands access after breaching a low-privilege account. These attacks often exploit unpatched software vulnerabilities, weak configurations, or flaws in access controls. Preventing privilege escalation involves applying the principle of least privilege across all systems, ensuring that users and applications have only the access necessary to perform their tasks. Regular patching also reduces the number of exploitable flaws available to attackers. Directory traversal is another common attack aimed at exploiting improper input validation in web applications. It involves manipulating file paths in an input field to access directories and files outside the intended scope. For example, entering //etc/passwd attempts to reach the system password file on a Unix-based server. If the application fails to sanitize the input, attackers can retrieve sensitive files or configuration data. To prevent this, developers must validate user input strictly, allow access only to specific directories, and implement filters that block traversal patterns from being executed. Man-in-the-middle attacks, often abbreviated as MITM, occur when an attacker intercepts communication between two parties without their knowledge. This allows the attacker to capture sensitive information, inject malicious content, or modify messages in transit. MITM attacks are particularly dangerous when data is transmitted in plaintext or over insecure networks. To mitigate this risk, systems must use encryption protocols such as HTTPS and virtual private networks. Proper certificate validation also ensures that users are truly connected to the services they intend to reach, making it harder for attackers to impersonate legitimate endpoints. Clickjacking is a deceptive technique where malicious actions are hidden behind what appears to be a harmless user interface. For instance, a user might click a visible button that is overlaid on an invisible frame containing a hidden command. This trick leads users to unintentionally perform actions such as changing settings, authorizing payments, or submitting sensitive information. Preventing clickjacking involves using frame-busting scripts that prevent web content from being embedded in frames, as well as setting content security policies that disallow this type of behavior. Users cannot see these protections, but they are crucial for securing web interfaces. Session hijacking is an attack where the adversary takes control of a user's active session, typically by stealing session cookies. Once the attacker has access to these credentials, they can impersonate the user and perform actions on their behalf. Session hijacking is frequently combined with other vulnerabilities, such as cross-site scripting, to steal session data. Countermeasures include setting cookies with secure flags, enabling session expiration after periods of inactivity, and requiring re-authentication for sensitive actions. These measures help ensure that stolen session tokens cannot be used indefinitely or without detection. Modern applications, especially mobile apps and web-based tools, rely heavily on application programming interfaces, or APIs, which can introduce security issues if not properly designed. Insecure API endpoints may allow unauthorized access to sensitive data or perform functions without appropriate authentication. Mobile applications may also store data insecurely on the device or transmit unencrypted information over the Internet. Preventing these vulnerabilities requires validating all inputs to the API, using encryption like HTTPS for all traffic, and avoiding the storage of unprotected sensitive data within the app or device. Application security testing is an essential process used to uncover flaws before attackers can exploit them. Penetration testing involves simulating attacks to find vulnerabilities in a system, while code review analyzes the application's source code for logic errors, security flaws, and unsafe practices. Static analysis tools examine code without running it, whereas dynamic analysis observes the application during execution. These practices are often integrated into DevSecOps pipelines, where development, security, and operations work together to ensure secure software is released and maintained. Even small organizations can benefit from periodic security testing and automated scans. A simple but dangerous scenario demonstrates the risk of SQL injection. Consider a web form used for administrator login that does not validate its inputs. An attacker submits a crafted entry like single quote OR1 equals 1, which causes the query to always return true. As a result, the attacker gains access to the system without needing valid credentials. To fix this, the input fields must be sanitized to remove potentially dangerous patterns, and the database should enforce strict permissions to limit exposure. Reviewing logs can help identify whether unauthorized access occurred and how the attack was executed. To conclude, understanding threats and vulnerabilities at the software and application level is crucial for both exam preparation and real-world readiness. Vulnerabilities such as SQL injection, cross-site scripting, buffer overflows, zero-day exploits, and man-in-the-middle attacks are often tested on the A+ certification. These threats can be prevented or mitigated through secure coding, strict configuration, input validation, and ongoing monitoring. While the exam does not require advanced programming skills, it does expect you to understand how these attacks work and how to respond appropriately using foundational IT practices. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.